Alright, so for this week's exercise, we're going to look at some health data. And I came across this thing called neighborhood deprivation, which I thought sounded kind of interesting. There's a project that put together this neighborhood deprivation index by census tracts for the U.S. They looked at 13 measures, socioeconomic indicators they found were associated with deprivation. Kind of have to laugh at these nationwide efforts because they might work for the lower 48, but for Alaska things can kind of get wonky. But I guess, in looking at this, it is amazing the amount of information that's collected in the America Community Surveys census or survey that goes out. Now whenever I get one, I usually try to fill it out because there's so much that you can do with the data that they collect. They are long surveys, but some of these things, percent of households without a telephone, I didn't know that they collected that information. So it just gives me ideas for what I could do for potential research projects. And so in your folder or on Blackboard, I will have the code book that goes with this deprivation index, which will tell you what the columns mean, and also the methods, in case you're interested in that. This is just one page of the methods. And so, as always, I have a little exercise to go through here. One of the things that we're going to just kind of show you is some relationships. These can be pretty powerful if you just want to compare what's within two different databases without actually physically transferring data among databases. And usually you have something that's called the primary key or the parent table, and this other one is called the foreign key or the child table. And basically you're trying to relate information in this table to this table, but not join it. So this is kind of the parent one, and this is the child one, trying to find its parents in this other table. And you can have different types of relationships, something called cardinality, which is a one-to-one relationship or one-to-many. So one-to-one might be, parcel to parcel, where you have one parcel and one database, and you have a parcel tax database, and the parcel's listed once. One-to-many might be where you have a customer and you have a purchasing database, so a customer can purchase many things. Many-to-many can get to be a little bit confusing. Say if you did have a parcel and it had multiple polygons with it, it was a really huge parcel and it couldn't be represented by just one single polygon, then you might have two polygons, so two rows in the parcel database, and then each of those parcels might have many buildings on them. So that would be an example of a many-to-many. But if you hear the word cardinality, that's what that means. We'll also talk about other places where you can get data. So there's ArcGIS has a living list of various topics, and they have online resources. So we'll kind of go into that, and that's actually kind of part of the data. What we're going to be looking at is this giscancer.gov. Pull it up here. Maybe. Okay. So this is what I came across with this GIS portal. One thing that I'm not very impressed with the GIS portal is they actually didn't include the spatial GIS data. So we're going to be looking at, I believe it was data on populations and social determinants, and then this socioeconomic. This is the data file that I downloaded. It's by U.S. states and census tracts. So just let me come here, click on this, and the thing is, they don't actually give you spatial data. They give you an Excel file, a CSV file, an Excel file. It would have been very nice if they actually gave us the census tracts that they used for this data, but they did not. And I went down here and I tried these, and they didn't really relate well. So again, data management is very important, but we're going to do our best here. All right. So go back to the Word document. Okay. Alright, so I'm going to move this off to this side of the screen so I can follow it while going through here. Alright, I'm going to open up ArcGIS Pro, start with a blank project, and then go and save it. Okay. Alright. I guess one thing before we get into our exercise, going in the future, if you do need boundaries for different census tract areas, census tract, you have block groups, you have blocks, the census has multiple nested scales. There is this mapping files, www.census.gov, geographies mapping files, and here is where you can get geodatabases, you can get shape files, and so, for example, the data we're dealing with is ACS data from 2017 to 2021, and so oftentimes that's listed as 2021, so I would click on here and go there. But let's just say, for example, we wanted the most recent data. You could go here and go to the geodatabase, Tiger Lines geodatabase, and let's see. Let's actually go 2021. Let's just pretend like we're actually doing it. And so for this, they actually have archived the different geodatabases for the states. So you could go to Alaska here, and you could download this database, Alaska's state number 2. This is Tiger Files Geodatabase 2021. And if we download this, we actually get all multiple levels. So I'll show you what I'm talking about here. And you don't have this data, but just running it through you. So in the future, if you're going forward and having to work with this, you know how to find it. So I downloaded this right here. It's a geodatabase. I click on it, go on the geodatabase, and you'll see I have block group, I have census tract, I have county subdivision. So let's say if we added county, census tract, and block group here, just to show you the nesting going on. You can see the block group is the most diverse. We see lots of different polygons here. Anchorage has tons of them. We take off the block group and we're going to go to census tracts, which may not look a whole different, but it is. See there, it's broken up some. Okay, and then we go out to county and we get even fewer polygons. You just look at the attribute table. You see you have your GeoID, county. These are kind of the unique identifiers. This GeoID census tract here has a GeoID to it. And then block group. Again, unique GeoID to it. So if you're looking to just kind of in one nice neat database get the different census or ACS extents, that's one way to go about and get it, is going there. So I'll remove this, go back here. You'll notice that there's really no US wide. I don't believe there's a US wide. The US is huge. You might be able to do it through this FTP, but even this FTP, like here's Alaska, Ohio, Oregon, what is this? Maybe Pennsylvania, Washington. Again, it's broken up. It looks like there is a national geodatabase here, so there's a national one. This one is pretty darn large. I'll just download it here. We'll see how long it takes for this national level geodesic. It'll take a while. But anyway, with your exercise today, originally I had started with the entire database for looking at national, for deprivation. So you go to the census track. I do have the US track information down. This is why it's in this funky projection. But you'll see one of the reasons why a lot of these nationwide efforts don't really work is the counties over here on the East Coast are so much smaller than the counties here in Alaska. So funny sometimes the results you get. I mean, they're doing this at the neighborhood level. Maybe that might fit on the coast, but neighborhood is not really going to fit in Alaska, looking at these large areas here. So the other thing that I found is, since they gave you the CSV file and they actually didn't give you the exact shape file that was used, a lot of the records for the lower 48 drop out. We don't have the corresponding shape file. I'm sure they did it just to save space, but it really kind of makes their data useless if you wanted to look at it spatially. So again, a bit frustrating. You guys are someday going to be in positions to make decisions, and I'd like to see people who are more aware of GIS and what data needs to look like to do GIS in the positions where decisions are being made. So I will take that off for that soapbox later. Alright, so we are going to go and add your data for this week. So you're going to have a file that's this Alaska track data. Add that. And then you're also going to have some deprivation data. See, I'll give you a DBF file. Yep, give you the DBF file. It was a CSV. I had to convert it. Okay, so if your projection isn't already in Alaska Albers, make sure to go to Map, Properties, and put it in Alaska Albers. Sometimes if you add the national databases, it's a very different projection than what you see. So it's in the right projection here. Alright, we're going to open up the attribute tables here. Let's look at them. Actually, I'm going to snap this one down here if I can. There we go. Alright, so I'm looking to see what's in common. So this neighborhood deprivation index was done at the census tract level and should have a field that matches with the actual GIS tract information. When I'm looking at this, I see that this track ID and this geo ID, they match pretty closely, but they're not exact. This has a 0 in front of it, and this does not have a 0 in front of it. I look at this. This is a double here. I look at this. This is a text field. So we want to have a field that's going to link these two together so I can join this neighborhood deprivation index to my spatial GIS data. I'm going to delete this off because this is what you guys are going to be doing. So, alright. In order to do that, we need to add a field. And since we looked and we saw that this one down here is a double, we'll make the exact same field called track ID. Make it a double. Okay. Hit save. Alright, so now we're going to have to use our field calculator and get the information out of this GeoID, but we need to drop this first 0 because it doesn't occur in this track ID. So it's a little kind of Python coding. So go over here and go to your calculate field. And so find that column, GeoID. And so we're going to want to go from 1 to 11. So we're dropping off that 0. That first Python usually starts the first character is actually 0, not 1. And so we're going to drop off that first one with this code. And then hit OK. Okay. Alright, so there we go. It's looking promising. This looks like this. This is a double, so that is correct. Alright, one thing I noticed is that the number of rows are different. So this has 177 and this has 167. So I'm kind of wondering which ones are missing. So if I was interested in knowing, okay, this 167, which are found in here, where am I going to be missing like spatial information without transferring data? You might want to use a relate instead of a join, and this is just to show how these work. So I'm going to click on my neighborhood deprivation table, and this is the one that's going to be like the parent table. So this table is the parent, or the primary key, and it's going to be looking for its lost little children in this table. Alright, so go up to relates, add a relate, and so the parent or the primary table is our deprivation. The relating field is going to be that track ID. The related table is going to be our spatial tracks, and it was smart enough to say, hey, you have another thing in here called track ID. So I've already done some checking here, and this column is unique and this column is unique. I have a question, in your worksheet, your exercise guide, to tell me how do you go through and tell whether a column is unique. And the most important things to figure out in your database is which is my unique ID column. And so they are a one-to-one, and then I'm going to name this, some relationship that I can understand. So it's going to be neighborhood, dep, relation to tract. That's what I'll call it. Alright, I'll hit OK. Now with relationships, they don't happen right away. You actually have to do them. And you have to have something selected. So I need to select some records in here. Since I'm just interested in all of these, and whether they occur in here, I could do, I can go here, and I can go up to all, select all records, so in this table, and then I go up to the related and I do the relationship. And so I can see, now how many records are actually found in this. So there are some records that are in this deprivation that aren't found in my census data and are going to be lost. It'd be really nice if they gave me the corresponding shapefile, but they did not. And so looking at the map, I can see this area isn't going to get any data, these areas here aren't going to get any, and here, so we'll have a less than perfect map. You can reverse this. Let's say if you wanted to ask a different question, where you're like, oh, I want to know if, let's see, I want to know if the North Slope is in this non-spatial database. What you could do is you could set up the join or the relate the other way. So you could highlight the track, and you go up to relates, and we can add a relate. So now this time, this is the parent one looking for its child in this non-spatial database. And we're setting it up in the opposite way, going track to neighborhood deprivation. And if you don't know if it's one-to-many or one-to-one, you're fine just leaving it as one-to-many. It's not going to break the bank. So we could do this. And now we can go up to our map, and we could say, I'm selecting the North Slope. And I want to know if the North Slope here is found within my non-spatial data. So make sure your A track is highlighted, your parent one, your primary one needs to be highlighted. Then you can go up the table, related data, and I see my relationship there. So I'm going to click on it. And yes, the North Slope is included in our deprivation non-spatial table. So we know it's there. And I could just kind of say, okay, is the Northwest Arctic Borough there? And You notice it didn't automatically do it. I still got to go up to, I got to click on this, I got to go up to table, and I got to relate the data again. But yeah, you always, it's there. I can see because this is the same. Let's see, this here is the same as what this here is the same. But in relationships, you gotta like always do them, and you can do multiples. So say if I wanted to see if Nome, Northwest Arctic Borough, and the North Slope were there, I can select all three, highlight my parent table, relate, and should I? Yep, all three of those census tracts do have data on their neighborhood deprivation. So this can be very helpful for just looking at your data without actually transferring information. Okay. All right. So now I'm gonna just clear all the records. Come here and clear this one. Okay. So we actually do want to join the data together. So we want to take this non-spatial database and join it to our tract database. So open up the attribute table for your spatial database. Go up to join, add a join. And the common field is that track. It's smart enough to automatically grab it. And then hit OK. Okay. Alright. Okay, so now it's joined. Let's go to our symbology here. And go over to, let's go graduated colors. And let's choose this NDIQUINT. Okay. And so we're looking at this and we can kind of see where our data dropped out. Here we have no data. If I do run into this issue, one thing that you can do is, it's hard to symbolize no data here. So what you can do is you can copy this, paste it back into your map. And then for this one, which is going to help symbolize the no data, here you could go to symbology and you could just put single color. And if you wanted this to be, I don't know, something like yellow. And that would symbolize, like in your map, you'd be like the yellow ones are the areas with no data. Now you can see them, which looks a lot better than just that. So it's a little trick to show where you have no data. Okay, so let's go back to our track information. And these labels you can play with, so it doesn't really make sense to have a label of 5 to 9 when 5 doesn't actually occur in the database. So let's click over here and let's just change this to 9. And click off. Okay, alright. So let's label the features in this database. So right click and go to label. And then go up to labeling. And let's label it with that NDIQUINT. Okay, you may be looking at this and you're like, oh, what the heck is this? This doesn't make any sense. I'm going to zoom in here to the Anchorage area. One of the things, this isn't a super good example of it, but some students have been noticing that when you have a really high tract density, it can get difficult to see what these are because the borders can obscure the information that's here. So, for example, if I added on the national data here, and you guys don't have to do this, just watch me do this, because I don't want to give you the national data because it will be a huge data file, so just watch what I mean here. Actually, I'm going to see if that other database downloaded. give it a try and see if it works any better. I'll extract it here. It might take some time. That's not too bad. So I'm going to try this other database. So if I go back here, I have a US track that I downloaded. Mount this all. And see if that other one is unzipped. There it is. So I mean, now when I see maps, you know, national maps that have information at the track level, national, I mean, it is quite hard to do. Data is huge. So interesting. Okay, I'm looking at this, and they did not even include the track information at this level. Just looking at it, statistical area. Wondering what this looks like, just out of curiosity. Okay, your core statistical areas, huh? All right, so I'm gonna go to this census track area, and again, just watch me. I created already this track ID here, and I'm just gonna go through the same process that we just did, but at the national level, and join in the US tracks. Okay, and now say I wanted to symbolize this. And I'll choose their numeric national deprivation index. I'll make this, I'll just keep it like that. So as you can see, it's pretty large. Okay, turn this one off. Turn that one on. And you'll see a lot of the US actually did not join together because of the lack of giving us an actual shapefile. But one thing that you see when you look at this, especially like Massachusetts here, it's just, it looks like a lot of gray. So it's the borders here that are kind of obscuring our ability to really see information. I mean, I can't tell at all what's going on in, I think that's actually Connecticut. Sorry, East Coast people. Alright, so what you can do is you can click on this top one, hold down the shift, click on the bottom one, and then you can right click and you can go to Format Symbol and drop this down to 0 so your borders disappear, and you can hit apply. And when you do that, it'll get rid of a lot of this grayness, and you're just actually looking at the color. So now I can see that this isn't all gray here. I can tell there's not a lot of dark places here. Connecticut is not a very deprived place in the US, which I wouldn't suspect it to have high rates of poverty and stuff like that compared with some of the other places. Yes, in fact, it is Connecticut, so I am right. Yay! Okay, so I'll just zoom back out. But that is a trick that you can use to update all the symbols and say get rid of that background, which might make things difficult when you do have a lot of little census blocks together. So I'm just going to turn this off for now, and so we'll go back to Alaska here. And I want you to do that for Alaska. So back to where you're actually doing stuff. We'll go here, click on it, hold down the shift, click on the bottom, go to right click, go to Format Patch, drop that buffer down to 0, and then hit apply. And it would make places like Anchorage where you can get, you know, higher density. It pops out a little bit more. Okay. So we have that. One of the other things is sometimes labels, you want to combine labeling and you just don't want to use a single column within the database. Or you want to, you know, I don't know, add your own information to a label. So right now we have this label of 3, 9. It doesn't make any sense what it is. So just so you know how to play with labels, you can go up to label and let's go to expression. And so right now this is telling us that we're labeling it just with this column called NDIQUINT. Well, what if I actually wanted to add in something else to this? So I can do plus, and let's say I'm going to do quote, dash, end quote, and then plus, and let's add on another column called this NDIQINT2. So what this is going to do is our label now isn't just going to say 2 or 3, 9, 4. It's going to say that, but it's going to have a dash, and then it's going to have the information that's in this other column. So hit apply. Oh, and my ArcGIS crashed. So I'll get that going and be right back. Alright, let's try this again. So we put the dash in here and feature, and I'm going to hit apply and hope things don't crash again. Let's see. Okay, so now you can see that we have the original value, dash, and then we have the information from this other column, which is more useful than just a number, that says whether it's an average deprivation, least deprivation, so that's really well off, below average deprivation, so also doing pretty well. So you can see here we've been able to combine a couple of fields to make more useful labels. I've used this for like the fuel treatment work that I've done, where you want to have like maybe AK dash and the fuel treatment number. Yeah, it can be very helpful. So just looking at this, you can now see that this 9 means, you know, they don't have any information on the national deprivation. So you might switch it to kind of no type of thing. This color is what this yellow is. So if you forget how to do that, you can go here, remember the symbology. We can click on this 9 and use the eyedropper. Maybe change that 9. This to yellow. There you go. So now all of those would show up as really no data. So there's the example for that. And then let's say it doesn't make sense to have this label here at all. We can go back up to our expression here, and you can go to this SQL query, and you can say, I don't want you to label it when this value is equal to 9, because I'm going to represent it with the no data. So you could go up here, and it's just like the definition query that you sometimes put in and say is not equal to 9, and then hit apply. And there, it goes away. So it's not going to label it if this should be equal to 9. So, yeah, I mean, there is, like I said, a lot of power within labels here and things you can do. I almost have a whole course, you know, on this. The last thing that I like to do with a lot of the labels is if I click here, it brings me up to kind of how I can change their appearance. It's very common to use something called halo. So if you have a very busy background and you want the labels to stand out, you can go to halo and you can make it white, hit apply, and see, it'll put a little halo around the back of it so it pops a little bit more. with the color, you can do gray. You can do something like that. Hit apply. And see what looks better. So it's not quite as stark there. But yes, so this halo is a very common tool that is used to help make labels pop. So I think I asked for you to take a screenshot of whatever map that you put together. It doesn't have to be fancy, but just to show me that you got the data in here, that we do have these missing areas here. Okay. I'm going to turn the labels off. There you go. Okay. All right, let's see. Now I'm going to export this as a new file. You guys do the same, so export this just so because we have the join on there, I just kind of want to make it permanent for the next part. So I'm going to call this AK_track_2001 and then NDI for the deprivation index, neighborhood deprivation index, and then hit OK. Make sure nothing is selected. Okay. Alright, so let's look at the attribute table. Okay, so you look at the attribute table, this ND is actually index. The one that we were looking at before is kind of where they just put it into categories. But there is actually a numeric index, so we could do our symbology by that. Okay. So looking at this, if we look in the anchor area, you know, there is some diversity in here. I would say the areas that are kind of most deprived are going to be the areas that are in darker color, so that have higher values here, so positive values. The darker color is higher values. The lighter color here is lower values. I might pick maybe some type of diverging type of color scheme. It's kind of hard on the eyes. But the blue areas are areas that are doing better than what the pink and purple areas are. Okay, so say we are interested in learning which of these various 13 ACS data points they collected are associated with the National Deprivation Index. So if you go to Blackboard, hopefully you have downloaded the code book. And with the code book, you can see what these mean. So medium household income, percent households receiving dividends, interest, rental income, public assistance. One thing that's good too to look at this is you can come up with a naming convention. Like PC is good, you know, for representing percent. You know, we can't spell it all out because of the limits on our file names, but you know, education. So they said education was going to be EDUC for every time they were looking at education. So it's just interesting to see how people do their data management and document their data. Also, it's important that they have the exact ACS table, so that if I'm a reader, I can go back and I can find this exact type data. So just thinking about management for you guys in the future. So we're going to see which of these is actually associated with this neighborhood deprivation index that they came up with. Okay? So to do that, we are going to use the ordinary least squares regression. So go to Tools, and there we go, it comes up. We'll click on that. And thinking about it, your input feature, just going to be this output file that we created. The OIDs are unique. We'll just let it create a default new feature class. The dependent variable is your NDI, and then your explanatory variables are going to be all of these. Okay, all those variables there. And the report file, navigate to somewhere where you're going to keep this. So I'm going to go to my drive here, folder. And I'll call it AK. Okay, so I'm going to call it. Okay. Let's do a coefficient table. I'll put that. And diagnostic. Save them to the regular device. And then hit run. So it'll run here. Alright, so the ordinary least squares did complete. There was an error window, just close it down. And so we do have, like this coefficient table that we can look at and see the probabilities. We could sort the probabilities, and ones that have lower values are more likely to be associated with our NDI index. And again, I ask you which ones are more associated with it. The best way to look at this, I think, is not really in the table, but I suggested that you save the PDF output. So if you go to where you saved it, here I have it. You could take a look at it, and remember the asterisks mean that it is significant. So I ask you which of the variables that we go through had the asterisk by it and is significant. And I would like you to give me the name of it, not just the short little abbreviation for what the column was called. So we want to use in combination this code book. I don't want this. I would like you to actually tell me what the parameter is that was significantly associated with the neighborhood deprivation index. So if you could do that, that would be great. And even though they found all 13 are important for their study at the nationwide level, not all 13 are important for Alaska. So anyway, I just wanted to give you some exposure to some of these national efforts that go on, and kind of some of the issues, with Alaska. I guess before we move on, if you look at this, you can see in here where you have kind of the estimated, the residual, and the standard residual. So where this is higher, it kind of means it's more, the model's more wrong. It's a bit off. So in here, it's kind of under predicting what the deprivation score would be. Here, the red is kind of over predicting what deprivation score would be. Personally, I think if we wanted to build an index for the neighborhood deprivation, it would be very different. We wouldn't probably do it at this scale, because this scale doesn't really make much sense, and I think there's parameters to include. But okay, this is kind of a mishmash, since this is the last exercise that I have for you guys. I wanted to expose you to some things before you leave the course. One of the things is this living atlas that is available. So pull up web browser here, and so there's Living Atlas of the World. ArcGIS actually takes a lot of the ACS data and other data sets and creates a living atlas of it. So you don't really have to create your own data. It's already all together. you know, I don't know, I'm maybe a control freak. I like to control my own data and build my own data sets, but you can add these to your ArcGIS project and take a look at them and see if something already exists for something that you're interested in. Like, I don't know, this healthcare coverage I thought was interesting because we're talking about healthcare. So if I go here and I can say add to ArcGIS Pro, you'll get this file that will open with ArcGIS. Just open with it and say okay. It's going to open up another brand new ArcGIS Pro application, which is fine. Once we get this open, we can just kind of drag the layer, say, back over to our health data that we're working on. Okay, so I'm just going to split my screens here and drag this over to my original health one. Okay, don't really want this other one open, so I'll go back to our health. Okay. All right, turn off these other layers here. Okay, and so as you'll see, the projection on the other one was a bit different, but we have this online living atlas, which means that it is updated as new data comes out. So, you know, I don't use these all that much, but I just wanted to let you be aware of it. So this is at the county level. What is the percent of the population that has no health insurance? And it's interesting. The South has a problem with a lack of health care coverage, it looks like. Alaska, I see lots of red dots here. The sizes, this is kind of where they're combining the sizes with the amount of data present. So this big red block here, so it's going to have low healthcare coverage, but it's also a very big population with no healthcare coverage. Down here is a big population, but moderate healthcare coverage. So again, remember, we had one exercise where we combined, you know, sizes with colors. That's exactly what they're doing here. And that's interesting. They have it set up so that it doesn't appear once you zoom in too closely. It goes away. I wonder if that's because they want to not have it be identified quite precisely. That's a tool that you can use to help protect privacy, is as you zoom in and have it go away. Yeah. And so, and this is data that, you know, if you like this layer, you could export it and then save it as a shape file on your computer. Okay, so this living atlas is one way to look at updated data. There's another way to look at data that you know, you might not own, and we can go up to add data. And you do have access to the living atlas here. So you could go and you could search up here for see if we search. Okay, it does pop up. Some of these do pop up. We saw this senior well-being. We saw that when we went back here. There was a senior well-beings right here, senior well-beings. So you can also access this data by going to this living atlas. ArcGIS Online also has data sets that people have posted to the internet. Like, I know I have some sites, I have some layers on here. Communities, okay. And take a look here, and I can see who the owner is of this data. Oh, there's one that I've already hosted. Right here is one that I've hosted that anybody can add. You see some from, you know, the Esri Federal Database. Maybe I'd be more confident in that one than just some random person like myself putting data up. Jen Jenkins, who works for the fire, put one up here. But this is a way where you can find any data sets. Let's see, imagery, way back. This is how one of my students found imagery of Alaska, historical aerial imagery. So imagery way back. Not that I think 2014 is way back. But I was asking her to verify field treatments, and she was using the online atlas, the online ArcGIS Online, to find imagery from way back. So you find all sorts of weird things. Let's see. Like I was doing on Alaska, and I believe like they have a cemeteries layer in here. Yes, cemeteries and grave sites. So you can find some really odd stuff. Your task would be to just search either the Living Atlas or the online one, and find a layer that you think is interesting, maybe helpful for your research, or just like, oh goodness, I can't believe someone posted this, and take a screenshot of it. Again, just trying to introduce you to different data sets that are out there. Alright, and one last random type of thing is that, suppose we had pictures. Someone was going out and documenting with their phone where they might see unsanitary conditions or really bad water sources, and they have the geotag setting turned on their phone. So each of their pictures is geotagged. I could see this with Bear Work in Juneau, say, taking pictures of where there might be trash cans, and, that might be an attracting, or other problems. You can add pictures to your map. So you have a folder called Stuck Again. So go to your tools here, your geoprocessing tools, and search for geotag photos. Go to that. And so navigate to that folder. What you want to do is you want to put all your pictures in one folder that you want to throw on a map. And so that's what I've done with this Stuck Again folder. It's from Fieldwork a couple of years ago that I had students doing. Here you go. Just click on the folder. Hit OK. And then I'm just going to change this to Fieldwork, even my default geodatabase, and then hit run. And so if your phone is set up and your pictures are geotagged, oh, I see the little photo icon. I'm going to zoom to there. And now I can look in here and I can see where my photos popped up. And I can even zoom in on one of these icons, and I can click on it and be like, okay, so with this point, it's associated with 3 different photos. They're all kind of the same. I can click on the photo and see what it is, my students in the fire department. And I can see where it is on my computer, which is very helpful if you're like, oh, where are my photos? I can know exactly where this photo is located. But yeah, this might be something helpful. It's even fun to do on a road trip. If you take geotagged photos, you can go in ArcGIS and make a map and look at, you can see what you saw along the stops, and be really nerdy like me. I've done it before when I was in the Grand Canyon, so it was kind of fun. But that's the last thing to show you. It's just one of the tools that I'd like you to have in your toolbox before we're done with this GIS course, is the fact that you can bring in pictures into ArcGIS. So that, and I ask you to either click on one of these other icons here, or go outside and take your own photo and try and import your own photo, or one that you've taken in the past if it's geotagged, and have some fun with it. But that is all for this week's exercise.